Hello there, Mr. Sutton here, bringing you the Algebra 2 7-3 Part 1 homework solutions on simplifying and multiplying rational functions. For this first problem, we're trying to simplify this rational expression. So let's first factor out what we can, and then we'll cancel out any common factors. The numerator can't really be factored, but the denominator, we can take a common factor of x out of those terms. So that leaves us with 3x minus 4. And then I can cancel out this x with one of the x's in the numerator. So when the dust settles, then we have just 2x left in the numerator and 3x minus 4 in the denominator. Now, since this x got canceled out and there's no other like singleton x's in the denominator, that means that if I were to plug 0 into the original, it would make the original undefined, but it wouldn't make the simplified function undefined. So I have to exclude 0. I have to say x does not equal 0 as part of my answer on this one. To simplify this rational expression, let's first factor everything we can. So for the numerator, I need numbers that multiply to negative 18 and add up to negative 3. So we've got 1 and 18 doesn't work, 2 and 9 doesn't quite work, 3 and 6 works if I have positive 3 and negative 6. So I can split this up into x plus 3, x minus 6. And then for the denominator, I need numbers that multiply to 6 and add up to negative 7. 1 and 6 will work if they're both negative. So we have x minus 1 and x minus 6. I see here that we have a common factor of x minus 6 that I can now cancel out. So that leaves me with x plus 3 over x minus 1. Now since I canceled out this x minus 6, that means I have to write x does not equal 6 as part of my answer so that we don't accidentally plug in things that would make the original undefined, even though they wouldn't make the simplified function undefined. To simplify this one, let me begin by splitting things up as much as I can. So for my numerator, I need things that multiply to 18 and add up to 11. 1 and 18 doesn't work. 2 and 9 works if they're both positive. So we have x plus 2 and x plus 9. Now for the denominator, I have a sum of 2 cubes, so I can use my shortcut for splitting that up. I'm going to take the cube root of each of these things, and that'll be my a and my b. So the cube root of x cubed is x, the cube root of 8 is 2, and I always have a sign that matches whatever this sign is in this first parentheses. So we have x plus 2, and then I'm going to have a squared, which is x squared. Then I'll do minus ab, so minus 2x, and then finally we do plus b squared, so that's going to be plus 2 squared, which is plus 4. So I can cancel out the x plus 2's. I know I can't factor this other piece anymore. This is always fully factored when you use this shortcut. So we've got x plus 9 over x squared minus 2x plus 4. And since I canceled out this x plus 2, that means I have to exclude x equaling negative 2 from my final answer here. Let's get started on simplifying this rational expression. This one is a little bit of a beast. So for the numerator, let me first look for common factors. I notice these are both divisible by 2, and I think that's about it. So if I take a 2 out of there, I'm left with 16x to the 4th minus 25. And let me also factor my denominator. There's no common factors I can take out, but I've got 4 terms, so maybe I can factor this one by grouping. Let me find out. So for the first 2 terms, those both have a 4 and an x squared that I could take out. That would leave me with an x minus 3. For the next 2 terms, I could take out a negative 5, leaving me with an x and a minus 3 as well. So when that gets factored, we end up with this x minus 3. That's our common factor. And the leftovers 4x squared minus 5. All right, well, let's go another round here, because right now it's looking like there's no common factors that I can cancel. So this 16x to the 4th minus 25 is actually a kind of an a squared minus b squared situation. It's the difference of 2 squares. So I can square root both of these terms and use a plus minus parentheses. The square root of 16x to the 4th is going to be 4x squared. Square root of 25 is 5. So I have the 2 there still, and I'm going to have a 4x squared plus 5 and a 4x squared minus 5. Denominator completely unchanged. But now I noticed, since I factored that, these 4x squared minus 5's can actually cancel out. So for my numerator then, I just have 2 parentheses 4x squared plus 5 and an x minus 3. Now since I did cancel out this other term, there's some x values I'm going to need to exclude from my final answer. To figure out what they are, let's set this expression not equal to 0, and then I can add 5 to the other side. And then to isolate x, I can just divide by 4 and take the square root of both sides. So the square root of 5 over 4, that would be the square root of 5 over 2, plus or minus, because we're square rooting an equation, kind of, sort of. So at the end of this one, x cannot equal plus or minus radical 5 over 2. So a little bit of an add-on to go with all this other work we did. For this problem, I'm multiplying these together. I'm going to try and cancel what I can, and then I'll just multiply whatever's left over. There's no factoring to do either. These are all just kind of single factors. So let's look at numbers first. 4 and 8 can cross-reduce or cross-cancel. That leaves me with a 2 down there and an invisible 1 I don't have to write up here. Next up, there's some x's I can cancel. The x here and this other x can cancel nicely. And then these y's can cross-cancel. So what's left in my numerator is a y cubed. And down here we just have a 2 and an x squared left over. Now since I did cancel out these y's, I'm going to have to exclude y equals 0 from this. So y does not equal 0. You might think, do we have to exclude x as well? Well, we did cancel out some x's. However, the fact that there's still an x squared in the denominator means that plugging 0 in for x would make my final simplified solution 0 as well as the original. So I don't have to spell it out for people not to plug 0 in here because they can already see this in the denominator. So only 0 equaling not equaling y has to be explicitly excluded. For this problem, I noticed that we've already got this thing pretty much fully factored, so that was nice of them to do that for us right off the bat. Let's just go ahead and cross off any common factors. So the x squared here and the x cubed, we can cross cancel those. That's going to leave an x in the denominator and no x's up here, at least no single x's. And then we've got these x minus 3's that we can also cancel out. And it looks like that's it. So in the numerator, we have an x minus 4 times an x plus 6. And in the denominator, there's just this single x remaining. Now since we canceled out these x minus 3's, we're going to have to exclude the x value 3 from our final function here. We also would have to write x does not equal 0 because we canceled out these x's, except that there's still an x in the denominator, so we don't have to spell that out. If you wrote x does not equal 0, it's just kind of being redundant, but you don't actually have to write it for this one. For this one, let me go ahead and factor out everything I can, and then I'll cross off any common factors. So in my upper left here, I can take an x out of that. So that leaves me with an x minus 3. And the x minus 2 and the x here are good, can't do anything there. Up here, I need numbers that multiply to negative 6 and add up to 1. So 1 and 6 doesn't work, but 2 and 3 would if I had negative 2 and positive 3. So x minus 2 and x plus 3 up there. And what can we cancel out? These x's can cross cancel. So can these x minus 2's. And that leaves us with just x minus 3 times x plus 3 in the numerator and nothing left in the denominator, so there's an invisible 1 that we don't have to write. Now in terms of things to exclude, these x minus 2's got canceled, so we have to leave out 2 and 0 also because of these x's that got canceled. So 0 and 2, x cannot equal those.